This video is on exercise 9D, questions 9 and 10 of A-level Maths Pure 2 textbook. So mostly these equations can be differentiated by using the product rule and the chain rule. So in 9a we have 2 sine x minus 3 cos x times ln 3x. So there's a temptation of expanding the bracket first and then starting the differentiation, but actually that's not always the best thing to do, because if we here expand this bracket, then we need to do the product rule twice, whereas here if we differentiate in a way that they have given us, then we only need to apply that once. So let's see. Divide by dx is equal to, I'm going to recall the product rule, which is, so let's say let's write here, we have two functions, which is, let's say our function y is equal to u times v, and then divide by dx is equal to u times dv dx plus v times du dx. And just remember that u and v here are functions. So in this case, we can consider this as our u and this as v. And then we can use this to differentiate. So now I'm going to write down the u bit first. 2 sine x minus 3 cos x. And this times the derivative of v. So ln 3x differentiates to 1 over x. Now this is the first bit, and now let's do the second part. In the second part, I should keep ln 3x, and this times the derivative of inside of the derivative of whatever is inside the bracket. So ln 3x times, so 2 sine x differentiates to 2 cos x, minus 3 cos x differentiates to, so cos x differentiates to minus sine x. Since here we have negative 3x, we get plus 3 sine x. And that's it. So we have done the differentiation. Of course, we can simplify this a bit, but it's not necessary because in the question they haven't asked for any specific form. So I suggest you to leave your answer in that form so you can save some time and also avoid making some errors. B, we have x to the 4 times e to the power of 7x minus 3. So we can consider x to the 4 as our u and e to the power of 7x minus 3 as v. And now let's differentiate this. So u times, which is x to the 4 times e to the 7x minus 3. So this 7x to the 7x minus 3 differentiates to 7, and 7 comes down times e to the 7x minus 3. And now let's do the second part. So x to the 4 differentiates to 4x cubed times v, which is e to the 7x minus 3. Now let's do question 10. Y is equal to x to the power of 5 times the square root of 10x plus 6. First of all, let's rewrite this as x to the 5 times 10x plus 6 to the power over half, because dealing with this form when we want to differentiate it's much easier. And now we can differentiate that so that we can find the gradient or the value of dy dx at this point when x is 1. Yeah, so again, we can consider this as our u and this as v, and let's differentiate that. So x to the 5 times, so u times dv dx, sorry. So when we want to differentiate v, we use chain rule. So the power comes down a half times inside, so 10x plus 6 differentiate, so 10 times the bracket, but with the power minus 1, which is minus a half, because a half minus 1 is minus a half. This is the first bit of using the chain rule. That's here when we do u times dv dx. Now let's do the second part, which is v times du dx. So this time we differentiate u, so x to the 5 differentiates to 5x to the power of 4 times v, which is 10x plus 6 to the power of a half. Of course, we can simplify this, but what I prefer here to do is that since here x is 1, substituting 1 into this equation and then calculating that is easy, right? So I think there is no need of simplifying that, but it's optional. So if you want, feel free to do that. So when x is 1, we have, now we substitute 1 into the equation of the derivative. That's all we are going to do. So 1 to the power of 5 times a half times 10 times 10 times 1 plus 6 to the power of a minus a half, plus 5 times, let's remove this bracket, so 5 times 1 to the power of 4 times 10 times 1 plus 6 to the power of half again, and we should get 21.25 as the final answer. That's it for this video. Thank you for watching. Please subscribe for more videos. Good luck.